is another pie that I've got my finger in. It's biodiversity data inventory, and it's the creation of geospatial consistent information on the distributions of animal pests and weeds. So here's an example of red deer, and I've brought it as a poster in the presentation. And the reason why Doc embarked on this project was for the Vital Sites project. And the Vital Sites project is basically, as Lynette touched on, it is creating over New Zealand basically layering all our biodiversity data geospatially from animal pests, weeds, threatened species, fire, values on classifications, so that we basically can take a square out of it and basically get these values of each layer, so we get a stack for an hectare, 1 hectare of information on what is in that hectare, and that information leads to a value of how vital that hectare is, whether it's not very valuable or not valuable according to various scientific criteria, and I don't know the in-depth how they run those algorithms, but that project BDI, Biodiversity Data Inventory, was going to be the base information on the threat layers. So it's a very exciting project. It's national coverage, so we went out to all our DoC staff, experts in our organization. So the Department of Conservation is split up in all sorts of area offices, and there's 56, including channels. So we met with representatives of all these area offices who had knowledge on weeds and animal pests, and we basically we conducted the investigation on 33 animal pests, and that's all the animal pests we know of, and 19 weeds, and those are the key weeds that we know of. And there's heaps of more work to do because there's thousands of weeds, but these are the key weeds that that always come to your fore. So we met with these area office staff, and we basically gave. Oh, sorry, I'll keep that there. Weeds. We basically gave them a map, in which there was a transparency, and a base map, which was a topological map for their area, and they would match perfectly. So you could basically overlay that on that. On the transparency, we had all the knowledge printed that we knew of that species. For example, for deer, we had a land care layer, and there was a spatial layer, but from 1995, and then we had deer kill data, basically GPS points of all the operations that we conduct in the Department of Conservation. So that was the transparency. We put it over on top, and we basically gave our staff a couple of those pins, and there were A1 maps, so they were fairly big. And we asked them, your role is to validate this information, and the red pin we use for where you know they're not, and the blue pin was where you know they are. So they started drawing basically on the transparency areas where they knew they were, and all these other ones, all the red areas basically they're not there, except for in those areas. So there's all polygons, and the accuracy turned out to be, these kind of paints on 300 meters. So because it was on a big topological map, 250,000 onto 250,000. So there's a bit of loss of accuracy, but we estimated that because it was the first baseline information, that after new refreshes or iterations, as I said, every 5 years we'd like to conduct a similar process, with that then become the baseline, and then over time we improve the quality of the information very, very much. So after this process, we basically, you can see it becomes like a jigsaw puzzle, and it's like 56 area offices, you know, like all need to be sort of matched. And there was some overlap because some area offices work in other area offices as well. So this information then was then digitized by a company called Geographics. We have advertising for them now, and they're here in on top of the hill by the cable car in the observatory. So they did an amazing job to digitize hand-drawn polygons into hand-drawn pictures, basically, into a geospatial usable format with amazing topology, very, very accurate. So what we have is basically 50-something maps of animal pests and weeds for the objective for vital sites, but at the same time it allows us then over time, with new iterations coming, it allows us to do an amazing analysis on status and trend of that particular species in the country, or in a conservancy, or in a smaller area, as to what are the shrinkage, what are the movements, and what is the impact that we have as organizations on the distributions of those species.